Hey YouTube, here's a video on a topic that I actually kind of hate because I'm a mechanical engineer, but getting a transfer function out of a circuit using Laplace transforms. So you're given a circuit in the time domain, and then you need to find it in the frequency domain, usually an output over an input. In this case, they want us to find the transfer function g of s, which is the output from this inductor over the input, which is just a power source. So first off, you need to convert everything into the frequency domain, which I'm assuming your professors told you how to do, but it's really basic. Let me just draw it all over again. It's my crappy resistor, it's my inductor, capacitor. Okay. So so you need to pay specific attention to anything that stores energy. So not resistors. That's just going to be a constant. So just write, it's 1 ohm, 1. It's a constant, that's it. So VI, for the N of T, we're just going to put in the frequency domain, V of S. And the voltage out, we're just going to put in S as well. So for inductors, we have to take the value in henries and multiply it by S. So this becomes 2S, and this becomes 3S. Capacitors are going to be 1 over the capacitance times S. So since it's a half, that ends up being 2 over S. And the obnoxious things about these problems are that your S's inevitably end up looking like 2's and 5's, and you start goofing up down the line. Or at least I do. Okay, so we're going to use mesh analysis, call this 1, call this 2, and let's get the equation for loop 1. So we've got I1 is going to be 2S plus 1. That's it. But we've got the current coming this way from 2, so write minus, because it's the opposite direction, 1. So 1, so just I2. And then minus VI of S equals 0, or you could just simply write equals VI of S. Simple enough. Let's go to 2. Alright, so let's do I1 first to keep, this all lined up. I1 is going to be negative 1. Easy enough. Everything I2 is going to be positive. So let's go ahead and do that. Let's see. It's going to be I2 3S plus 2 over S plus 1. And that equals 0. Oof. Okay. Can we make that any simpler for us? Not easily. These get really unwieldy, especially when you've got 3 loops. In fact, it becomes an absolute disaster. But let's make a matrix and take the coefficients of each current. So we've got 2S plus 1, negative 1, VI of S. Over here, negative 1, 3S plus, honestly, capacitors are what makes this a nightmare. This 1, and then this is 0. Okay, so what you need to do is take an examination of your circuit. So you want this over here for out. That has to do with the whole reason for going to the frequency domain is because you can relate capacitance or inductance to current. So by relating it to current, even though, one deals with voltage and one deals with current typically, it makes it a bit easier, in quotes, to analyze the circuit. So let's just go ahead and do that. Let's say, we can say basically, VO of S ends up equaling, it'll be L, the inductance, S times I2. So we know this is 3, so it's going to be 3 SI2. So let's find I2. if you took linear algebra, you would know of Cramer's method, where you basically take, so this is I1, this is I1, this is I2, this is I2. So, in fact, if I was being proper, I would write is that right? I think that's right. Yeah. So you need to take the output, put it over what you're trying to find. So this is I2, and divide it by the determinant of right here. So you get 2s plus 1 VIS negative 1, 0 over the determinant of this. Let's do that, because that's going to be, the annoying part. So that ends up being, let's see, that ends up being 2s, well, hold on, 6s squared, just take 2s and multiply each individual term, plus 2s plus 4. Now do the 1 plus 3s plus 2s plus 1. And then that whole thing is going to be subtracted. You subtract 1, so that goes away. Okay, so let's shore this up. Collect our terms. And that goes down here because that's the determinant. Okay, so now let's do the top, which is nice and easy. 0 minus that, which ends up being just VI. So the whole thing is just VI. Okay. So we know, so I apologize, this is I2. So the whole thing on top is just VI. So we know that the O is simply 3s this. So let's do that. VO equals VIS times 3s over that. Okay, well, we're halfway there. We want to divide it by, we want this relationship. Well, look at that. That just makes that go away. Okay, so you could leave it at that. Some professors are finicky and will make you pretty it up. If you do want to pretty it up, you would just multiply top and bottom by s. So just s over s to get rid of that. That would give you 3s squared, 6s cubed plus 5s squared plus 4s plus 2. And there's your transfer function. That is the output voltage over the input voltage over the 3 Henry inductor.